With today's lesson, we're beginning lesson 7.2, which is entitled Equations with Rational Numbers. And for our first lesson here, we're going to be looking at 7.2a, solving an equation that involves fractions. So if we remember back to Module 1 when we were talking about rational numbers is any number that can be written as a fraction. It doesn't have to be written as a fraction, but it can be written as a fraction. So in 7.2a, we're going to be solving equations that involve fractions. 7.2, we're going to be solving 7.2b, we're going to be solving equations that involve decimals. So for today, again with fractions, our goal is to learn to solve equations that have fractions as either the coefficients or the constant terms. Now if you remember back to 7.1a, we talked about what it means, what a coefficient is, and what a constant term is, and what a variable is. So if your constant term is a fraction, or if your coefficient term is a fraction, or both, we're going to talk through how to go about solving these problems. And all it really involves is taking a single extra step at the start of the problem to actually eliminate the fraction terms. Now usually when I make these videos, what I do is I go onto my HRW and I look at the homework that you're going to be assigned, and I look at your turn that you're going to be assigned, and I try and identify any difficult problems that you guys might have and try to show examples that will help you to more easily navigate how to work through those difficult problems, especially when it comes to the drop downs where they're looking for you to insert words and that type of thing. Unfortunately, I'm not able to get on my HRW tonight for whatever reason, so we're going to go through examples from the book, and hopefully it will give you guys enough information and enough direction in order to solve these problems. If you have any questions or problems, please feel free to message me, and we'll go through and address those issues as they arise. But again, going back to lesson 7.1a, I gave you guys 3 steps in that video lesson that can help us solve equations with variables on both sides. That's what 7.1a was about, solving equations with variables on both sides. Now with 7.2, we're taking those 3 steps and we're adding a single step prior to us getting to those 3 steps. So let me go ahead and give you that first step that you're going to need to take with these problems when you might have a fraction as either a coefficient or a constant term. So step 1, and again we take this step prior to steps 1 through 3 from 7.1a. What we want to do is we want to eliminate all of the fractions in the equation, and we do that by multiplying the entire equation by the LCM, that's least common multiple of all of the denominators in the equation. Let's take a look at an example and see how this can be done. Alright, our first example, we have 7/10 n plus 3/2 is equal to 3/5 n plus 2. So what we're doing right now, again, we're trying to eliminate all our fractions. We do that by finding the LCM of the denominators. So denominators, we have 10, 2, and 5. We need to find the least common multiple of those 3 numbers. So I want to recap how to find least common multiples of 3 or more numbers, just so that we have that in our back pocket for when we're going ahead and finding LCMs of the denominators. I'll come back to this problem in a moment, but for now I just want to maybe set some space aside to talk about finding LCMs. Now if you feel confident with finding least common multiples, that's great. I still want you to copy this down just as a refresher. If you don't remember finding least common multiples very well, that's fine. We'll go over that just a moment. So our first denominator that we had, or one of the denominators that we had, was 2. Another one that we had was 5. And the last one that we had was 10. So if we multiply all 3 of these numbers by 1, we get 2, we get 5, and we get 10. But what happens if we multiply each of these numbers by 2? We're going to get 4, 10, and 20. Those are all multiples of 2, 5, and 10. What we're looking for is we're looking for the same number to appear at least once in all three columns. So we're looking for a number to appear here, the same number to appear here, and the same number to appear in this column. If we get to the point where we have a number, the same number, and the number again, then that number is our least common multiple. So right now, I look here and I see 10 here and I see 10 here. But as of yet, I don't have 10 in this column. So I'm going to keep going with my multiples. Take 2, my third multiple will be 3, so I will have 6. That's supposed to be a 6. 5 times 3 gives me 15. Little editing there. And then 10 times 3 will give me 30. Alright, still I don't have a number that appears in all three columns, so I'll go on to my fourth multiple. 2 times 4 gives me 8. 5 times 4 gives me 20. And 10 times 4 gives me 40. I still don't have a number that appears in all four columns, so I'll go one more, see what I can find. My fifth multiple, 2 times 5 is going to give me 10. 5 times 5 is going to give me 25. 10 times 5 is going to give me 50. Now I'm going to pause and take a moment and look at what I have here. Because if I take a moment and actually look at my columns, I notice, alright, earlier I saw 10 here and I saw 10 here. Now I get to the point where I have 10 here as well. 10 is the smallest number that I have in all three columns. Therefore, the LCM, or the least common multiple of 2, 5, and 10, is going to be the number 10. Alright, so we're going to use that LCM with a value of m to help us eliminate the fractions in our equation. And here's how we'll do that. We've determined that our LCM is 10 for 10, 2, and 5. So what I'm actually going to do is I'm going to wrap the entire equation in parentheses. And I'm going to multiply the entire equation by 10. Okay? Or if we want to think about it as 10 over 1, that might help us see what's going to happen to our fractions a little bit better. So I have my 10, or my 10 over 1, and I'm multiplying it by all of my terms inside my parentheses. So I'm going to multiply 10 by this term, going to multiply 10 by this term, and by this term over here. It's essentially a large distribution problem. Just for a minute, I'm going to take this and move it down here to get it out of my way a little bit. You guys don't have to worry about this. Don't feel stressed out if you obviously can't do that on pencil and paper. I just want to show you the process of the distribution that I'm going to do when I multiply my LCM, my value of 10, by all four of my terms. So I'm going to start by taking 10 over 1 times 7 over 10. If multiplying fractions is something that you have a tough time with, I get it, they can be tricky, but we just have to keep in mind, we can either cancel, we can do any canceling up front, then multiply, or we can multiply straight across, then simplify. It's up to you. I'll show you for this first fraction, I'll show you both ways. Now, the way that you would go about canceling this is we notice that we have a 10 in the numerator and a 10 in the denominator of the fraction that we're multiplying it by. Now when we cancel those, it goes to a value of 1. So here I have 1 times 7 gives me 7, and then 1 times 1 gives me 1 for my denominator. Now I don't need to have that over 1. In fact, my goal here is to eliminate my fractions. So if I ever end up with a denominator other than 1, something is wrong. We need to figure out what went wrong. Okay? So I'm trying to get rid of my fractions, so I'm not going to write that over 1 as part of my fraction. Okay? I'm trying to get rid of them. So I've gone ahead and I multiply my fraction, but I cannot forget about my variable here. Okay? I need to make sure that I bring that variable with. So it's going to be 7n. Okay? So that's multiplying our first term, 10 over 1 times 7 over 10. Now, if you don't like that method of canceling then multiplying, you can instead multiply then simplify if you so desire. I think this way is more work. I would encourage you to shy away from this method and do it the first method where you cancel then multiply, but it is, and in the end, it is up to you. So I'll show you that one as well. So what we would do if we're going to multiply then simplify, we're just going to multiply straight across. So we'll start by multiplying 10 times 7, gives us 70. Then we multiply 1 times 10, gives us 10. We bring down the n. Now we simplify that fraction. 70 over 10 is going to give us 7n. Okay, our answer is the same. Therefore, I would encourage you to use the first method where you cancel first, then multiply. That will make sure that you're saving yourself some time and some effort. And it's the method that I'm going to be using for the remainder of the video, canceling, then multiplying first. So now I move on to my next term. I'm going to bring down my plus sign so I don't forget about that. I'm going to take my 10 over 1, multiply it by 3 over 2. So we should always end up with our numerator of our LCM canceling the denominator of our fraction. So 10 and 2, 10 goes into 2 5 times, 2 goes into 10, 2 goes into 2 once. So now we end up with 5 times 3 equals 15. Keep moving along. Going to bring down my equal sign. Now I'm going to take my 10 over 1, multiply it by 3/5 n. So 10 goes into 5 twice, 5 goes into 5 once, and so we have 2 times 3 equals 6, and I don't forget to bring down the n. Now for my last term, I'm going to multiply 10 over 1 times 2. Don't overthink this. There is no denominator here, so we don't need to write one down. It's a mere 10 times 2. Bring down the plus sign, gives us 20. So instead of dealing with 7/10 n plus 3/2 equals 3/5 n plus 2, instead of trying to deal with this equation here, we're now going to work on solving this equation here, which we know how to do from what we learned how to do in lesson 7.1. Because we know how to do this equation already, and I've taken 13 minutes to get through one example, I'm going to move on and show you guys another example instead of finishing this one out. If you have questions about how to finish this one out, please feel free to reach out and ask. But all that work that we did there, that's just taking this single step where we eliminate the fractions. We see that we started off with fractions in the equation. We had 3 fractions here. We eliminated all those fractions by multiplying by the LCM, and therefore we're left without any denominators. No denominators in this new equation. If we do have denominators, something went wrong. Okay? Let's go ahead and take a look at another example. Example 2. We have 5/6 y plus 1 is equal to negative y over 2 plus 1/4. Now, the thing that catches my eye about this problem is this negative y over 2. If you haven't seen a problem like that before, I just want to make sure that you understand that negative y over 2, and you don't have to write this down, is equal to, it's the same thing as negative 1/2 y, just written a different way. Okay? So if you feel more comfortable, please feel free to put a coefficient of 1 in front of the y. If you feel even more comfortable, feel free to take this y, move it behind the fraction. Absolutely fine by me. Just want to point out that you can have the numerator or have the variable in the numerator, and it will still mean the same thing. I do also want to say though that I don't want to see you putting negative 1/2 y like this, because to me that looks like the y is in the denominator, which if you put the variable in the denominator, that will change up the problem. Variable in the numerator is fine, variable in the denominator changes up the problem. So make sure that you're aware of that. Now getting back to our problem. we have three fractions again. 5/6, 1/2, 1/4. We do have this negative sign here, but we're not worried about negatives when we're trying to find LCMs. So I'm going to go to a separate sheet again to find my LCMs. If you want to do it right underneath the problem or off to the side, again, that would be fine by me. So our numbers again are 2, 4, and 6. Now if we multiply 2, 4, and 6 by 1, we're just going to end up with 2, 4, and 6. So let's go to our second multiple, multiplying everything by 2, and we get 4, 8, and 12. Now at this point you might notice that we have a 4 here and a 4 here, but we're not going to end up with a 4 over here because these numbers are going to keep getting bigger. So we have to keep going with our multiples until we find a number that is in all three columns that's the same number. So our third multiple, 2 times 3 is going to give us 6, 4 times 3 is going to give us 12, 6 times 3 is going to give us 18. And so now we see a couple more pairs come up. We see a 4 here and a 4 here. I think I pointed that one out already. A 6 here and a 6 here, but we're not going to end up with a 6 in the middle. So 6 is not going to be our LCM. We also see that we have a 12 here and a 12 here. Well, if you want, you should know that 12 is going to be a multiple of 2. Okay? All even numbers are going to be multiples of 2. So we can keep going down our list here. 8, 10, and 12. So our LCM of these three numbers, 2, 4, and 6, is going to be 12. So what that means is we're going to have to multiply the equation by 12 in order to get rid of all our fractions. So coming back to our problem, again we have to remember to multiply our entire equation by 12, or if we want to write 12 over 1, that would be fine as well. So I'm going to give myself a little bit more room here to show my arrow where I multiply my LCM, my 12, by each of my terms inside my parentheses. So starting off, 12 over 1 times 5 over 6. Well, 6 goes into 12 2 times. 6 goes into 6 once. 2 times 5, I take this 2 times this 5, is going to give me 10. I need to make sure I bring down my variable y. So I end up with 10y as my first term after multiplying 5/6 by 12 over 1. Now for my next term, I'm going to multiply 12 over 1 times 1. I bring down my plus sign, and 12 times 1 is just going to give me 12. Move on to my next term on the other side of the equal sign. So I'm going to bring down my equal sign. Remember, we keep our equal signs in a straight line going up and down when we're solving our equations. I'm taking my 12 over 1, multiplying it by negative y over 2. Well, 2 goes into 12 6 times. 2 goes into 2 once. 6 times negative y is going to give me negative 6y. And finally, for my last term, I take my 12 over 1, multiply it by 1/4. Well, 4 goes into 12 3 times. 4 goes into 4 once. So 3 times plus 1 will give me plus 3. Now this equation looks much more manageable, much more solvable than what I had up here. So, just to recap, I took this equation, found the LCM of 6, 2, and 4, and that value happened to be 12. So I took that 12, multiplied it by all 4 terms inside my equation in order to eliminate my variables. And now that I've eliminated my variables, I end up with a problem that looks exactly like what we had in lesson 6.1a, and I'm ready to solve. If you have any questions about how to solve the problems, if you're still struggling with that part, reach out, message me, and we'll talk through it some more. Or if you have questions about how to find the LCM or how to multiply the LCM by our terms inside our equation, message me with that as well. Be more than happy to help you guys out with these. So again, in this lesson, I did not take us through the entire process of how to actually solve the equations. We talked about when we learned how to do that in 7.1a. Our goal for this lesson was simply to take the fractions that make up the coefficient or the constant terms and eliminate those so we have a much nicer equation to go ahead and solve. Any questions with this? We'll talk about it in class on Thursday. I will have a bell work problem on Thursday similar to this that I'll have you guys work on so that we can talk through it together one more time as a class. Message me with any questions that you might have.